This video will cover section 2.8, and this is part 2 on the topic composition of functions. Alright, the composition of functions involves when you take one function and place it inside of another one to create a new function. Alright, so if you'll think back to when we first started talking about functions, remember we said f of x, and then we used f of 2. And when we had f of 2, that meant we took the value 2 and we put it in place of all the x's in the function f. Alright, well this principle works similarly, except instead of replacing the x's with a number, you're going to replace the x with another function. Alright, so when you're talking about compositions of functions, these are the two ways you're going to know it's composition of functions. You have f, and this little circle here does not mean multiplication, it means f of g or f composite g. So we're going to compose these two together. Alright, and it's written as, or you can read it as f of g of x. Alright, you may also see it written like this. So inside the parentheses of the f, alright, notice instead of a number is the function g of x. So in the function f, everywhere there's an x, we're going to replace that x with the function g. Alright, similarly, if I have g of f of x, then what I'm going to do is everywhere in the function g, instead of replacing that x with a number, I'm going to replace it with the function f. Alright, so let's take a look at a couple of examples. Alright, we're given the function f is the square root of x plus 4, and the function g is 2 over x. And we're asked to find f of g of x. So we can rewrite it like this, f of g of x. Alright, we're going to take the function f, which is the square root of x plus 4. Alright, and everywhere there's an x, we're going to replace it with g. So instead of writing x plus 4, I'm going to write 2 over x plus 4. And then that would be my new function. Alright, then what I want to find is what is the value of that function when x is 2. So I want to find f of g of 2 like this. Alright, and so everywhere there's an x, I'm going to put a 2. So here, instead of writing the x, I'm going to write a 2. 2 over 2 is 1 plus 4. And 1 plus 4 is 5. So the value of that function would be the square root of 5. Alright, let's take a look at another. This time we're asked to find g of f of x, and then find g of f of x's value when x is a 5. So what we're going to do is we're going to take the function g, so I'm going to write it like this, g of f of x. Remember, these two things mean the same thing. Alright, so I'm going to take the function g, and it is 2 over x, but instead of writing the x, I'm going to write the function f, which is the square root of x plus 4. Alright, so that will be my new function. Now what I'm going to do is find the value of that function when x is a 5. Alright, so we have 2 over the square root of, and instead of writing x, I'm going to replace it with the 5. So then we have 2 over the square root of 5 plus 4 is 9. The square root of 9 is 3. So the value of our function when x is a 5 would be 2/3. Okay. Alright, so next we're asked to find f of g of x and then give the domain. So we're going to replace everywhere there's an x in the function f, we're going to replace it with a g instead of a number. So f of g of x, I'm going to take the function f, which is the square root of x minus 1, and instead of writing x, I'm going to write 2x plus 5, because that's the function g, and then minus 1. So 2x plus 5 replaced the x. Alright, now I'm going to simplify that, and that'll be 2x plus 4. Alright, now we're asked to give the domain. So remember, anytime you have a square root function, the domain is found by taking the radicand. That's what's under the radical sign. So 2x plus 4. And remember, the value that's under here can't be negative, so it has to be greater than or equal to 0. So what we do is we find what makes x be greater than or equal to 0. I do that by subtracting 4 from both sides, divide by 2, and I find that x can be any value negative 2 or greater. So if I write that, my domain would be any value negative 2 to positive infinity. Alright, I'm asked to do the same thing except this time with g of f of x. So g of f of x, I'm going to take the function g, and then everywhere there's an x, I'm going to fill in the function f of x. So instead of writing an x here in the function g, I put the entire function f of x. Alright, then I multiply that out. Alright, and I get 2 square roots of x minus 1 plus 5. Alright, now this is still a radical equation. So to get the domain, I'm going to take the radicand and set it greater than or equal to 0. Remember, the domain are all the possible x values. Alright, and then I solve and I get x can be any value that's greater than or equal to 1. And I would write that as 1 to infinity.